Let's work through some examples involving trig functions and their inverses. Note that in these examples here, the functions and the inverses are going to be mixed, so we're not going to be able to use the cancellation properties that we have seen before. So in this first example, number 1, we have the sine of the inverse cosine of a half. And so to compute these values, we just need to work from the inside out. So the inverse cosine of a half means we're trying to find the angle that makes cosine a half. So the cosine of theta is a half. And from our unit circle, we know that cosine is positive in the first and the fourth quadrant. And the inverse cosine has to give us an angle in the first and the second. So we can go ahead and find the angle using our unit circle in the first quadrant that makes cosine a half. And so that would be theta is equal to pi over 3. So the sine of the inverse cosine of a half will equal the sine of pi over 3. Because again, that pi over 3 is the angle that's produced by the inverse cosine of a half. And then again, from our inverse circle, from our unit circle, we know that the sine of pi over 3 is going to be a square root of 3 over 2. So going back to the original problem, the sine of the inverse cosine of a half is going to equal the square root of 3 over 2. For the second one, we have the sine of the inverse tangent of 3/5. And so when we think of the inverse tangent, remember that produces an angle. So we really want to figure out, solve the equation, the tangent of theta is equal to 3/5. Now notice that 3/5 is not one of our nice sort of unit circle values. Usually for tangent, we would like to see 1 or a -1, 0, or square root of 3 or 1 over square root of 3, which this obviously is not. And so how we figure out what the angle is that makes tangent equal to 3/5 is a little harder. Okay, so we would actually need technology to do that. But we don't need technology to do the whole problem here. Because remember, if we can figure out what this tangent of 3/5 is, then we can go back and use that to compute sine. And we can do that if we think in terms of a right triangle. So let's draw a right triangle here, and we have an acute angle theta. And from tangent, remember tangent's opposite over adjacent. So the tangent of theta being 3/5, we could say for the acute angle theta, the opposite side of the triangle would be 3, and the adjacent side would be 5. So we have a right triangle with acute angle theta, opposite side is 3/5, adjacent side is 5. And we then want to compute, remember the inverse tangent of 3/5 produces an angle. We then want to compute what is the sine of that angle. So to compute sine, we need to have opposite and hypotenuse. So we need to take this triangle and compute the length of the hypotenuse. So if we think about Pythagorean theorem, the hypotenuse is side C. So we're going to have 3 squared plus 5 squared is equal to C squared. So that's 9 plus 25 is equal to C squared, or that would be 34 is equal to C squared, which means C is equal to the square root of 34. Okay, so we have the sine of the inverse tangent of 3/5, but that inverse tangent of 3/5 represents theta, and so we can replace that inverse tangent of 3/5 in our problem with just a theta. So we really just need to compute sine of theta, and if we use this triangle that we've just drawn, sine is going to be the opposite over the hypotenuse. So the sine of theta is going to be 3 over the square root of 34. Okay, so if we back up to the original problem, the sine of the inverse tangent of 3/5 will equal 3 over the square root of 34. All right, number 3, our last one here. We're trying to do the inverse cosine of the tangent of pi over 4. Again, we can't use our cancellation properties because tangent and inverse cosine are not reciprocal or are not inverses of each other. So we just work from the inside out. So tangent of pi over 4, that's a nice unit circle problem, unit circle angle. And so we know that tangent at pi over 4 is equal to 1. And so that we can simplify our expression a little bit. From the inverse cosine of tangent of pi over 4, we can now say that's equal to just the inverse cosine of 1. And we can again use our unit circle to figure out the inverse cosine of 1. Remember, when we do inverse cosine, we need to find an angle between 0 and pi. And remember, cosine is the x-coordinate. And so the point 1, 0 has an x-coordinate of 1. And that corresponds to an angle of 0. So that means the inverse cosine of tangent of pi over 4 is equal to 0.